So quickly, the hints for all the sums I've mentioned here. Very nice worksheet, very important as usual. Carries only few sums and takes care of everything. Find whether the lines this and this intersects or not. What we do, we take each of the lines like x minus 1 upon 2, x minus 1 upon 2 is equals to y plus 1 upon 1 is equal to z plus 1 upon 0 equals to lambda. Find x, y, z in terms of lambda. So we get 2 lambda plus 1, y is equals to lambda minus 1 and z is equals to 0 into lambda gone, so minus 1. That means we know the z point where the line is intersecting z axis. Then the other line is x minus 2 upon 1. So x minus 2 upon 1 y plus 1 upon 1 is equal to z plus 1 upon 0 again equals to, suppose, something mu. Then x should be equals to mu plus 2, y will be equal to mu minus 1 and z is equals to minus 1 again. Now coming to the point, if these two lines are intersecting, then these x, y, z will be same at the point of intersection. So we equate the value of x with x, that is 2 lambda plus 1 should be equals to mu plus 2. Then lambda minus 1 should be equals to mu minus 1 when I equate y, and z is equal to minus 1 is in both, so nothing to be equated. It's already true. So we equate, like we solve these two equations. From this only we get lambda is equals to mu. See, lambda is equals to mu because minus 1 cancels, and we put mu as lambda. We get 2 lambda plus 1 is equals to lambda plus 2. So we get lambda is equals to 2 minus 1, so 1. That means lambda is 1. Now generally what happens, z will also be in terms of lambda and mu. If we put lambda value or mu value, both values basically, in z, like when z is also in terms of lambda and mu, they'll come same. That means these are intersecting. Here z is coming already same, so obviously we already know that they are intersecting. We are only finding out the point of intersection here. So I'm putting lambda as 1 or mu as 1 because they are equal. We can get the point of intersection. It will come x equals to 3, y is equals to 0 and z is equals to minus 1. So 3, 0, minus 1 is the point where they are intersecting. Fine. Next question. Find the equation of the plane passing through. So I should tell you a shortcut directly. Equation of a plane passing through three points x1, y1, z1, x2, y2, z2 and x3, y3, z3 is given by x minus x1, y minus y1, z minus z1. Then do for x2 minus x1, you can take any order. You can write x1 minus x2 also, that won't affect it. y2 minus y1, z2 minus z1, and the third row, you saw, no? I am doing a determinant basically. Yeah? Third row will be x3 minus x1, or even x2 will do. Y3 minus y1 and z3 minus z1 is equal to 0. Note this formula down. This formula is used to find out the equation of a plane passing through three non-collinear points. if you get, while solving, everything vanishes to give you 0 equals to 0, that means points are collinear, huh? Important point. But if it is not, if the points are not collinear, then you will get some answer, and that's the equation of the plane. Now, please note this down. Now, we find out the equation using these 3 points. That's pretty easy now. In that, we put x, y, z as minus 4, 4 and 4, and we see that it satisfies, it gives you 0. Then, all the 4 points are coplanar. This is the way to prove coplanarity of planes. Fine? Of the points, basically, not planes. Coplanarity of the points. Next question, find the point on the line this at a distance of 5 units from the point 133. So, equate this whole thing to lambda and get xyz in terms of lambda. Now, so we got the value of x is coming out to be 3 lambda minus 2. 3 lambda minus 2 is your x. 2 lambda minus 1 is your y. 2 lambda minus 1 is your y, and 2 lambda plus 3. 2 lambda plus 3 is your z. This point's distance from another point 133, 1 comma 3 comma 3 is given as 5 units. So use distance formula, and you know the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square, you know, z2 minus z1 whole square whole under root is equal to 5. Square both sides, put these values in x1, y1, z1, x2, y2, z2, get the value of lambda, and that lambda you substitute back here and you'll get the point on the line. Alright. Next question, very important, find the image of the point 134 on this. So we have a plane here, and we need to find out the image of 134, 2x minus y, 2x minus y plus 3z. No, 2x minus y plus z plus 3. Plus z plus 3 equals to 0 is the equation of the plane, and there is a point whose reflection is to be found out. The point is 134. So 1 comma 3 comma 4's reflection, getting me? Like this point is the foot of the perpendicular. From there, go equal distance down, and this will be your image. Huh? So suppose this point is P, then this point is P dash to be found out. Let's take the foot of the perpendicular as alpha, beta, gamma. And let's take this P dash, let's call it something Q. Let's call P dash as x1, y1, z1. Now we know that alpha minus 1, beta minus 3 and gamma minus 4 are the direction ratios of PQ. But PQ is normal as well. So its direction ratios are actually 2, minus 1 coming from here. Huh? 2, minus 1 and 1. So these should be in same ratio because it's the same normal, equals to something, say lambda. So we'll find out alpha 2 lambda plus 1, beta minus lambda plus 3 and gamma which is lambda plus 4 cross multiplying. Huh? These points alpha, beta, gamma lies on the plane as well. So should satisfy 2 alpha minus beta plus gamma plus 3 equals to 0 as well. So put the value of alpha, beta, gamma here and you'll get the value of lambda. Knowing lambda, you get this point. The point Q will be found out. Now to find out this p dash, very simple, we know x1 plus 1 upon 2 will be equals to alpha, the midpoint. y1 plus 3 upon 2 equals to beta. z1 plus 4 upon 2 should be equals to gamma. Knowing alpha, beta, gamma, we can just get the value of x1, y1, z1 from this. Fine. Please note this down and see that what answer you are getting. Find the distance of this from the point of intersection. Very simple sum. Now you know already. You know, point of intersection of a line with a plane, I've already explained that in one of my videos, is very important. Huh? So here what we do, we'll find out x, y and z in terms of lambda. I'll substitute here. Getting me? Now, when we substitute like 3 lambda plus 2, 4 lambda minus 1, 2 lambda plus 2, here we get the value of lambda. And when we put lambda back here, we get the point of the plane and the line intersecting. Huh? Now there is some other point. There is a point somewhere whose distance is to be found out. Okay. So that we can find out using distance formula. Got it? So there is a plane, there is a line that intersects it, and there is some third point somewhere, second point, and that point's distance from this point is to be found out. So that's what is this whole question about. Fine. Find the equation of the plane passing through the point this and containing the line. So this is coming from the same concept, intersection of two lines. Basically what we have a plane, and on that plane we have two lines intersecting. So first we find out the point of intersection. How? By equating along x, y, z the lambda and mu values. And as I explained already, we find out the value of lambda and mu, substitute in the third, and we'll get the point of intersection by putting it. So this point is the point. Fine. Now the direction ratio of this line and this line known already, we can find out the normal of the plane, which is B1 cross B2. Getting me? Like the normal to this plane will be cross product of the directions of the line, because normal is perpendicular to the plane. So that way we get the direction ratio of the normal. Now equation of a plane you know is A, x minus x1, B, y minus y1, and C, z minus z1 is equal to 0. So we use this equation where A, B, C are the direction ratios of the normal found out through cross product of B1 and B2, and x1, y1, z1 is this point through which the plane is passing and containing these lines of intersection. Fine. Now the next part of the question says show that this plane contains the line this. Now this plane will contain the line if this is perpendicular to the normal. So let's call it B, suppose, then n dot B should be equals to 0 is one condition, and the other condition that this point should satisfy the equation of the plane. So you do two steps here. You first substitute this point in the equation of plane and it will satisfy. That guarantees that this point is on that plane. But it's not yet known that that line is going to be fully on the plane or is just cutting it. So we do B, n dot B, and if that comes 0, then you understand, like this is the plane, then we have a line which is such that it's perpendicular to the normal and the point on it satisfies the plane. So this has to be on the surface only. So that's how we prove that a plane is going to contain a line. Huh? Find the little plane passing through this and perpendicular. So very simple sum. Just the direction ratios of the normal to this plane are 1 is to 2 is to 3, and the other one is 2 is to minus 3 is to 4. Take these two direction ratios and find out the cross product of these two vectors. So I, j, k, 1, 2, 3, and 2 minus 3 4 will give you the normal vector n. Okay, because both the planes are perpendicular to them. Huh? Now we know normal and we know the point. So what is the formula? Please don't use those bookish formulas. Huh? R minus A dot n equals to 0. You can use that, I don't mind, but there's no point, man. It's so simple. It's A x minus x1 plus B y minus y1 plus C z minus z1 makes it so clear. Fine. So it's better to use this, I feel. Otherwise, whatever you're comfortable with, you can use. Find the foot of the perpendicular drawn from the point this to the line joining the point this and this. Pretty important sum, because it's not a crammed one, that you know the sum already. It's like 2 points are given, B and C, and then there is a point A, and from there we have to drop a perpendicular, and then we need to find out this coordinates of D. So because B and C are known, 471 and 353, 471 and 353, and point A is also, let's take D as alpha, beta, gamma as usual. Huh? And coordinates of A are also known, is 1, 0, 3. 1, 0, 3. So, the direction ratios of this will be alpha minus 1, beta minus 0 and gamma minus 3, doing D minus A. Huh? Also, equation of this line can be, or direction ratios of this line are nothing but 4 minus 3 or 3 minus 4, you can take anyway. So, 4 minus 3, 7 minus 5 and 1 minus 3. So, these direction ratio of BC and these should multiply to give you 0 because they are at 90 degree. Fine. So, 1 into alpha minus 1 plus 2 into beta minus 0 plus, so minus 2 into gamma minus 3 is equal to 0. So, we open this up, we get one equation in alpha, beta, gamma. But we know the equation of BC also, because that's going to be x minus 3 upon 1 equals to y minus 5 upon 2 equals to z minus 3 upon minus 2 equals to some lambda. What I did, I used this point as x1, y1, z1 and the direction ratios of BC to find out the equation of BC. You can use 471 as well. The same answer will come. Now, though equation will look different, but eventually it will give you the same points. Get x, y, z from this, which are nothing but alpha, beta, gamma, because lies on the line. Let me make it clear to you. Huh? This point alpha, beta, gamma lies on this line. So, I will put x, y, z as alpha, beta, gamma and find out alpha, beta, gamma in terms of lambda. That we substitute here as usual. And then we get lambda. Knowing lambda, we put it back here and we get the point. Fine. 9th I am leaving for you. You should try this on your own and ask me in the class. And 10th, whenever we need to find out the plane passing through the intersection of two planes, okay, we always do one plane plus some constant lambda times the other plane equals to 0. What I want to say is 2x plus y minus z minus 2 plus lambda times 3x plus y plus 2z minus 4 equals to 0. This will be the equation of the plane passing through the intersection of these individual planes. Now, because it passes through origin, we can put 0, 0, 0 here and we'll get the value of lambda. Knowing lambda, we put back lambda here and we get the equation of plane. Alright. So please give it a try and talk to me in the class. I'll explain everything if something is not clear.